Assalamualaikum warahmatullahi wabarakatuh and greetings to everyone. So for this topics, in this video we're going to cover an introduction to functions. So the learning objectives for this topic are you are able to use the basic terms used in function, mapping, domain, and also range, or it is also called an image. And second objective is to identify the types of mapping of a function. And the third objective is going to find the domain and the range of a given function. So mappings have different types. So there are three types for mappings. So it is 1 to 1. Okay, 1 to 1. Okay, say it 1 to 1, many to 1, and 1 to many. And you are also looking at the definition of a function, and when you are given the domain set, you are able to obtain the range of a function. So with that, before I start to deliver the examples and the explanation of the content, please try to do the starter by your own, and I will pause the video for you to answer this question below. Given that y equals to 6x squared plus x minus 1, find y if a, x equals to negative 2, and b equals to x equals to 1 over 4. Please try to answer the above starter. And I will pause the video now. Alright, now these are the answers to the starter. If you use calculator to calculate the substitution of x equals to negative 2, you will get positive 21 as your y. And as for the part B, if you substitute x equals to 1 over 4 into the given equation, you should have y equals to negative 3 over 8. Alright, now in this page, in your notes, it will be a page 1. So if you go below, these are the types of mapping. So if you already watched the video that I suggested for you to watch, before you start watching this, you will encounter the word input and output. So the set of inputs over here, so you see here, there's different numbers in the set of input. And if you have a function that will process the input, you will obtain an output for each number in the input. So this is an example of mapping diagram. So a kind of example function is, for example, fx, x is mapped to x plus 1. So here, if you try to plot a graph based on the values, you will have this diagram or graph. So this is how this is look like, for the diagram of x plus 1 function is also can be translated into graph. So this is the notation that you can also use, but sometimes or most of the time you will see this form also, which is fx. Right now, below, for the diagram above, you see in the sentence from the diagram above, for one input value, there's just one output value. So this is an example of 1-to-1 mapping. And if you go further down in your notes, this is the different types of mapping. So the first one is called 1-to-1. For one input value, there is just one output value. As for the second one, which is many to 1, so for two input values, there is one output value. And as for the third one, 1 to many. For 1 to many function, you will see that there is one input value. For one input value, it will produce two output values. So here, if you try to give a value for the graph, right? So here, let's say that your input is 3 for this 1-to-1 mapping. So the product or the output will be x plus 1, which will give you a 4, right? So say if you go further down, I mean, if you use another value, for example, -2. So -2 plus 1 will be -1. So here, because of the graph that you produce, it will only produce like one input, one output. Right. Now, if we go to the second one, which is many to 1, so here, this says the function is x squared. Okay, this is also y equals to x squared, or f to x is x squared. So here, for example, if I input 2, you will get an output of 4, right? But then, at the same time, you can see that it is possible to have an input of -2. Because here, basically, if you have to square 2, you will get a 4. But at the same time, if you square -2, it will also give you a positive 4. So that's why this is a many input to one output. As for one to many, this is a case where you have square root of x, and its effect in maths that if you square a number, you should have a positive or negative number. So this is the reverse situation in this example above. So here you can put 4 as your input, but then you will have your 2 and -2 as the output, because this is plus minus square root of 4, right? So it will give you plus minus 2. Okay, so this is for one to many. And if you notice in the video that I have given you the link before, if you watch it, this not a function. Okay, the third type of function, the mapping, this is not a function. Okay, only the first, which is one to one, and the second one, which is many to one, because you're supposed to only produce one output. All right, moving on to the next page. So this is the definition of a function. Okay, strictly enough, it is saying that a rule that maps each x value. So it doesn't matter how many values you have, either the one value for one x value to one y value, or 2 or more x value to just one y value. Alright, so this is the explanation of the mappings, one to one or many to one. Those are the only ones that we can call function. Alright, an example one-to-one function is the mapping. Okay, this is the from the previous example, where this one, okay, a new notation for you. Since mathematician likes to abbreviate statements, so the meaning for this is actually just x is a real number. So real number consists of numbers that you can use to calculate. Okay, for example, integers or fractions or decimals. Other than real, you call it imaginary. The opposite of real is imaginary, but you will learn imaginary numbers in a further higher level of maths. For example, A-level maths. So I'm not going to touch on that. And below here, this is a notation of function. Yeah, notation. So notation is like when you see it is written in textbook, you will know instantly the use of it as a whole. So here, you have sometimes in some textbook it write f colon x, but a most common one that you will use in the whole additional maths lesson is this: f to the x, or f as a function of x. Right now, fx itself, okay, means when you plug in x as the input. For example, if you have fx equals to x plus 1, so here when you input x equals to 2, so the function will produce 2 plus 1, so it will give you an output of 3. So f2, okay, is the output. So the output equals to 3. So for example, another example, if you put in f3, so x is 3 as the input, but the output is f3. f3 equals to 4, and so on. Okay, now to make sure that you understand that the function involves sets of numbers or collection of numbers, So the collection of the set of input values of a function, we call it the domain of the function. And as for the output values, we call them the range or image sometimes of the function. So it depends on the function that you are given, whether it is one-to-one or many-to-one. Okay, now for example, okay, one of the most common example or questions that we'll ask from you to answer is whether you can find the domain and the range. And in addition, you also need to know how to sketch a graph. So if you watch the video that I have sent the link to you, you will know so far it is shown only 4, which is linear, quadratic, cubic, and also trigonometric. So the first 3 graphs, you will learn to sketch them in this year. So as for the trigonometric function, it will be covered in year 10, so not to worry about that too much. But let's begin. So in this question, okay, fx equals to 2x minus 1, and x is a real number, and -1 less than -x, positive x is less than 3. So in this question, okay, let's understand first what is the meaning of this. Okay, so here, if you haven't covered this in your previous years of learning mathematics, this is actually talking about x in 2 conditions. So here, the first one, if you split them into 2, x is less than 3. So which means x are numbers that are 3 and below. But at the same time, x must be more than or equals to -1. So here, both of them will give you a list of x that starts with -1, 0, 1, 2, and 3 as a whole. But then the notation or abbreviation for this both situation, okay, x is less than positive 3 and x is more than or equals to -1. Okay, the abbreviation is this one. So learn how to use this, and you will see it again in your mathematics D. Alright, so that's the meaning of this notation. Okay, so which means, okay, you are actually answering the question part A, which is the domain of the function. The domain of the function, okay, domain, just to recap, domain is a set of input values. So x are the input values. So the domain of your function f here is -1 or less than x, or less than or equals to +3. So in English, you can also, this is actually from x is the values from -1 to +3. Alright, so moving on, okay, for the part B, sketch the graph of the function f. Okay, so here there's an additional instruction usually used in past year papers. Please add this down. Okay, stating the coordinates. Stating the coordinates where the graph intersects the axis. Okay, axis, the plural for x and y axis. But then the instruction is usually this one, okay, the ones that I highlighted here. So which means the graph that you will have later, okay, the sketch of the graph, okay, for example, this is not correct yet. You will have something like this later, okay, and then in order for you to get a full mark in sketching, you have to tell the intersection of the graph with the x and y axis. So here, number 1, you have to tell the value of this and also the value of this part. Okay, so with that, let's begin on how to sketch the graph of this function. Now here, the function is fx equals to 2x minus 1 with the input or the set of input or the domain -1 to +3. So my suggestion here is for you to begin with what is the beginning and What is the end of the graph? Horizontally. So here horizontally, the first value that you will use is -1. And then the final value for this graph is x equals to 3. So we are looking at the end point of the graph. And this graph is linear, by the way. So you are going to produce a straight line, uphill or downhill. Okay, let's see. So here, let's put in the input value of x. Okay, input, say here -1. So the working that you will do is going to be fx equals to 2x minus 1. So 2 bracket, you can guess it, -1 minus 1. So this one will produce -3, right? So the coordinates that you will plot later in this graph, okay, no need to be too accurate, okay, because this is on the sketching. So the coordinates is going to be -1, -3, so it is going to be in this quadrant, right? So if this is quadrant, then say estimate, you can estimate it to be over here maybe. And okay, you don't need to actually tell the coordinates, but for the sake of this lesson, please give the coordinates. Okay, write down the coordinates of the point. Okay, as for the next value, f input f of 3, yeah, x equals to 3, so the working is the same, 2x, which means 2 times 3 minus 1. So this will give you 6 minus 1, which is 5. So the next coordinate is going to be 3, 5. Okay, where y is a 5. Right, so 3, 5 may be somewhere around here. Okay, please write down the coordinates also. And you can actually, okay, you can actually draw the straight line straight away. Use a ruler to do this. Alright, but then this one, okay, not really that good, so I'm going to give it here. Okay, so please make sure. Okay, I want to show the intersection with the axis clearly. Alright, now this is the complete graph, but then it is not full yet because you also need to state the coordinates where the graph intersects the axis. So in this case, you have a point on the x-axis, okay, this one, and also you need to also find the point of intersection with the y-axis. So here, for this one, okay, please write down also, you will always use this when you are sketching graph. Okay, at x-axis, okay, interesting about x-axis points, okay, if you put in a random number, 3 or 4 or 5, for example, so the coordinates of these points, okay, consistently, the coordinate of y is always 0, right? So this is read as 3, 0, 4, 0, and 5, 0. So with that knowledge, if you want to find the points on the x-axis, you have to substitute y equals to 0. So in this case, your y equals to 0 is the fx itself. So fx in your example given above here, okay, so please substitute 0 as your fx equals to 2x minus 1, and you will find the x value. So 2x minus 1 equals to 0, 2x equals to 1, which will give you x equals to 1/2. So that means the value on the x-axis, okay, is going to be 1/2 or half, right? And as for the y value, y-axis value, so you can already guess, okay, on y-axis, the value of x is constantly 0, so you have to substitute x equal to 0. Alright, so which means your function is going to be calculated as y equals to 2 times 0 minus 1. So which means y equals to -1. So in your graph, y equals to 1, okay, on the y-axis. So this is a complete graph of linear function. Okay, you can always use these two facts. Okay, please write down these two, find out when you want to obtain a graph of any graph that requires you to find the intersection with the axis. Alright, moving on to the next one. Okay, this is a quadratic graph, because you can see here, if you expand the x minus 2 square, this will give you quadratic format, which is ax square plus bx plus c, right? Okay, now the function f is defined by fx equals to bracket x minus 2 square plus 3 for the domain of x from 0 to 6. Okay, the instruction here are sketch the graph of the function, and with the sketching of the graph, you have to find the range of f. Alright, yeah, I forgot about part C for this one. Okay, sorry about that. Okay, let's go to part C, which will ask you on how to find out the range of this function. Alright, now, as you can see from here, from the graph itself, okay, your domain is already stated as -1, 3. So if you look at the graph, -1, -3 is the x value for the set of the domain. And you have to look at the graph horizontally first. This is your domain. Okay, the domain, or the limit of your graph in a way. Yeah, and then as for the range or the image, okay, you have to look at it vertically instead of horizontally. Okay, so vertically, the range is here. Okay, horizontally, when you look vertically, when you look at the graph, the range is here, and you can already tell the values or the set of values used, okay, or you obtain after you sketch the graph. So it is from -3 to +5. So for C, the range of function f, okay, is going to be, okay, list down the values first, which is -3 to is it 5? Yeah, it's going to be 5. And then since your domain is written in this form above, your range is going to be also written in the form above. Okay, similar form, but the subject of the range, okay, actually you can use y, okay, because that's the y value, right? But then in order to be more specific, you have to use the name or notation of your function, which is fx, or you can leave the letter f also. Okay, you can use the letter only f, but then you have to make sure it's specific fx, okay, over here to be safe. So the answer is going to be, right, 3 less than fx, less than 5. All right, going back to the question number, example number 2. So this is a quadratic function. Okay, just background information on quadratic. Quadratic graph can be two situations, which is, okay, there are two types. Okay, you can see. Okay, you will learn it in the future. There are two different graphs of quadratic function. So here, for the first one, okay, the first one you will get it if you have positive a in front of x squared. So for example, if you have positive 5x squared or positive 6x squared, something. All right. And as for the second one, you will get this if you have negative a. So for the numbers in front of x squared, it is, for example, negative 5x squared or negative 6 or negative 7 or something like that. Okay, so in this case, in general, for this example, it is going to be positive x squared. So you are using, you will get something like number 1 later. Okay, right. So the graph for number 1 or number 2, I usually remember it as smiley face and a sad face. Okay, right. Okay, so let's start with sketching of the graph. Okay, please write down the function itself, which is fx equals 2 x minus 2 square plus 3. So here in mathematics world, this form of function, the format of this, okay, the format of this quadratic expression, we call it completed square form. Okay, completed square form, in which you we learn it in quadratic spots in algebra in both maths D and additional maths. Alright, now why do I have to tell you about this one? Because completed square form has it will give impact to on how you look at the graph itself. Okay, now completed square form format is you can use it to get what we call turning point. Okay, you will obtain what we call turning point because at certain point in the graph, okay, if you go, like, let's use example 1. Okay, let's use the first graph. Okay, when you go down the graph, you will notice that there is a point, and in which afterwards you will turn the graph upwards. Okay, or the second one, if you say here for the second one, going uphill, and then after a certain point it will go downwards. So this specific point we call it turning point. Okay, turning point, there are two different kinds, okay, of turning point. Okay, there are two different types of turning point. Okay, in the first condition, the first graph, we call it a minimum point because it's the lowest point of the graph. And as for the second one, okay, you can guess it, we call it a maximum point. Okay, depending on the graph situation. So here on I will not really explain long on that part. Okay, how do we find completed square form? The turning point for the completed square form, you start with this one. Okay, the part that I box here, make it equal to 0. That's the starting point. So which means if this part is a 0, x minus 2 squared is a 0, x minus 2 is also 0, right? Because you move the square to the right side, square root of 0 is 0. So the x for this one is going to be 2. So that's the x coordinate of your turning point. Okay, that's the x coordinate of turning point. And as for the y coordinate of the turning point, because this is a 0, so you are left with fx equals to 3, which is y equals to 3. And there we have it. This is the coordinates of your turning point. Okay, so in this graph, your turning point may be somewhere around here. Okay, maybe somewhere around here. Okay, so that's your turning point. Okay, let's write it down as 2, 3. Alright, now as for the others, anything that we would like to continue to sketch. Okay, if you want to continue to sketch this one, you have to also proceed with the same way we have done above in the above example. So here you are using using the x point. Okay, plot in the most left value and the most right value. So here in this case, the beginning or the start of your domain is x equal to 0. Okay, so here f input 0 as your x. Okay, so you will have x minus 2 is 0 minus 2. Okay, 0 minus 2 square plus 3. So this one is going to be negative 2 bracket square, which will give you 4. 4 plus 3 is a 7. So plot in 0, 7, and coincidentally that's your value with the at the y-axis. Yeah, so say estimate 7 over here. Okay, this one must be stated because it is on the y-axis. Okay, intersection of the graph with the y-axis. All right, and as for f6, okay, this is the end of your value of x, the domain. Okay, by the way, this is optional because it is not intersecting any x or y axis, right? So here, just calculate, okay, just to be safe. Okay, let's estimate where it is going to be later. So 6 minus 2 squared is 4 squared, 16. 16 plus 3 is 19, right? So let's plot it somewhere. So 6, 19, maybe it's here. Okay, maybe. Alright, so just plot the coordinates. Okay, this is just for the lesson, and in general, Okay, this is going to be your graph, right? Okay, you can actually you can pass through the, and you cannot pass through the domain. Sorry about that. Okay, so this one, okay, let me adjust this a bit. Okay, maybe the graph will be up till this point only. Okay, this is the graph up to that point. Alright, so that's the sketching complete. Okay, and then finally let's find the range of f. Okay, the range of f, and f is fx, huh? Okay, f is also fx. You can actually lose the input. Okay, you can actually optional. Okay, now here, if you are trying to find the range of f, okay, for this graph, see here, okay, vertically, the range is starting from here. It doesn't go below this point, right? So this is not the range. The range is going to be above this. It's going upwards, right? Because the graph has a turning point, okay? Hence, the why we need to find the turning point, it's because it is going to help you to find your range. Okay, so here, your range is starting from 3 and it goes above. It will never go below. Okay, because based on this graph, the value of the range, okay, it starts from 3 and it will go above. So if you try to translate it in terms of inequality, okay, which one are you going to use is, okay, your subject is fx, right? The value of the range is from 3 and it will go above. So you have to use the inequality more than or equals to. Okay, based on your domain, the equals to is included, right, here. So your range for this function is more than 3. Alright, so here, okay, you can also you say that, but then this is sorry, okay, but this one, okay, a bit of a mistake. Okay, this is when you have to, okay, when your domain is, remember, x is a real number in this part, right? But here, because your domain is limited to 6, okay, you are going to use, instead of just 3, it is going up to only 19. Okay, this is your range, right? So it is going to be the same or similar to what you have answered in example 1, which is using from one value to another value. So here, this is 3 to 19. So write down 3 less than fx less than 19. So this is the final answer for the range, right? So that's all for the introduction to function. Okay, so just now, just to recap back a bit, okay, there are different 3 types of mapping, but only 2 of them are function. The third one is not a function. And you have seen the definition of domain and range, and also the notation for function. Okay, and you have seen the sketching for linear graph and quadratic graph. Just a bit of introduction, okay, here. So I will see you next time in the next lesson. Hopefully you're doing fine there. Thank you very much. See you next time. Assalamualaikum warahmatullahi wabarakatuh.